Okay. I think we're good to go. I think. And just let me share the link with to the live video. We're going live, don't worry, we're not going public this time. We're just gonna go here. I don't even know where to go. Okay, there, we're fine. It's frozen. Thank you. Okay, in your book, this thing's facing you. Let's have it face you guys. Chapter 6? What's chapter 6 Okay, remember how I introduced this class last time? No. I was talking about talking about a lot of things. We were talking about drugs, talking about Mars, the aliens, Arnold Schwarzenegger. Well, that's why I'm here. What else we talked about? Family, relationships.
About our savings.
Right.
Taxes. No, we need people.
Yeah, what you're gonna call your kids. And I landed like 5 seconds before the class was over. And then I said they're going to either share or swap from each other. I was watching the stream video from the last class in the morning, and wow, that cell phone's ringtone sounds very loud. You know, notification. I'm putting vibrator. Let's check how many people we have online already. This is, yes, there's one person. Whoever is watching right now, please check in, saying hi in the live chat here on YouTube. And if you have any questions, just put it there in the live chat. I try to extend the screen in such a way that I could see the screen there and the live chat over here, but the encoder, I feel so technical saying that word. The encoder was not able to detect it. If I put it here, I was protected. Alright. Let's get to the nitty-gritty real quick. Promise I won't talk too much. It's mostly classwork, especially given the fact that it's the last time of the day. It's the last time of the day. Okay, so page number, can you remember? Then you have what we just said right now. Chemical bonds. Chemical bonds are forces that bind atoms together. That's very important. You guys like black. Black. Very important to say that chemical bond is a force that joins atoms together. Okay? It bonds atoms together. Why? Because elements want to follow the octet rule, which is what's symbol there, which is 8 electrons in their outermost shell. What is an exception to this octet rule? Hydrogen is an exception to the octet rule. Why is hydrogen an exception to the octet rule? They can only hold 2 electrons in their outermost shell. What is another exception of this octet rule? Because they usually do not react. There are exceptions to this also. There are some elements that actually can hold or bond up to 10 electrons. But those are very, very rare exceptions. There are other compounds in which you only have elements with 6 electrons and they're happy. Okay, these are guys that settle for less, but there are others that want more. But they're very rare exceptions.
But they want to have 8 electrons in the outer.
Yes. Yes. If you were to make an electron configuration of all the elements, you will notice that depends on which group they are. 1A, 2A, 3A, 4A. If we were to make an electron configuration of all atoms while they're bonded, we will find out that all of them have 8 electrons in the outermost shell. But we're not going to do that, okay?
The outermost shell is the resonance shell.
Yeah. That's energy level. So, I don't know what's going to happen if I make a new screen, so I'm just going to erase it. Yes.
You said that the noble gases want to have 8 electrons. That they already have.
The noble gases, yes.
But how do we
Remain 8. They're noble gases. Alright, now, let me write again. Chemical bonds. It says chemical bonds in here, I promise. Let's do. We like this type of charts. We have 3 types. 3 main types of bonds, which is metal plus non-metal, and we have metallic. Metallic bonds, which is obviously metals.
metals, like texture.
Yeah.
And
That will get for
So, when they have ionic, it's like
oh no, it's when you see a metal bond with a non-metal, you automatically say that is that compound for the atoms. 1 atom of oxygen. A unit. No. Covalent bonds forms molecules. Okay? And ionic bonds, they form crystals. Okay, they form crystals. Not units, not molecules. Please keep that in mind, okay? That's very important that you know. That ionic bonds, they form crystals. They do not form molecules. And we will see, there's Diego. And let's say that Diego has a They're doing a tug of war. They have the same strength. Who wins? No, right? Okay. Now let's say that we open the new one at the risk of messing up with. Okay. Yes. Somebody was. Yeah, let me see if it's still streaming that screen because it might not be. Oops. I'm sorry, what? It says the stream resume. That green bar means that it is. Right. Why did it go away? But here it says it keeps streaming. Stream resumed. There, look. It says stream is continuing. Like it's going on and off.
No, you're live.
Yes. What happens if I refresh? I'll refresh. Where did it go? Welcome back. Let's see. But this is not moving. Oh, look, it is moving now. Yeah. I did that like 5 minutes ago. What does this mean? I'll try. I don't have an iPhone.
She has iPhone. She has it.
Oh, but you're thinking about traveling to the other side of the house?
But only 2 more. WhatsApp.
Okay. What was I saying? Yeah, I'll say the first question. Alright. Somebody got a question? So far? No. Alright, so here's an atom of hydrogen. Again. How many electrons does hydrogen have? It only has 1, right? It has 1.
Yes, 1.
That's 1 Vegas electron. So I'm going to delete 1. And I'm just going to draw the other hydrogen in a different color. And I'm going to put the atom in there. Why in there? Because it's going to look better for the purpose of putting it together. So, this hydrogen says, the red one, that doesn't, you don't see that camera, right? Is lonely. Or is sad because it only has 1 electron. Okay? So here comes another hydrogen. And it's also sad. And then they say, hey, why are you sad? Well, because I only have 1 electron, and I wish I had 2. You know what? I'm sad also. So then they say, hey, I have an idea. Why don't we share? So then, yeah, that sounds like a plan. Come closer. And then what you have here is these 2 electrons are being shared. This electron over here is being shared with these 2 electrons are traveling around this hydrogen, but they're also traveling around this other hydrogen. Okay? Forming a structure that looks something like what you see on page 152. Can you please go to page 152? On page 103, yes, figure 6.3, figure 8. Okay, you have a cloud that looks something like that in the case of hydrogen. Okay? Now, let's wipe off this story. I'm going very slow here, okay? I hope. Let's draw the molecule of the atom of it's an example here. I want to use an example in the book. Now, fluorine. Let's go with fluorine. Fluorine has how many electrons in it? Can you see that? You see it? No? I'm taking a color that's different. Okay, so we have fluorine. that has how many electrons in the outermost shell? 7. So we can go and say 1, 5, 6, and 7. And here we have hydrogen with 1. So fluorine has 7 electrons, has 1. He wants to have 2. So they meet. You know, why are you sad? Well, I'm sad because it turns out that I would like to have 2 electrons. And then fluorine says, hey, electron with me, and I'll share 1 electron with you. Such a way that we're both, I'm going to have 8, which is what makes me happy, and you're going to have your 2. Excellent. So, you're in hydrogen. Let me share my electron with you. It doesn't matter where you put hydrogen, okay? That's not really relevant. And then I'm going to share with you. Now, fluorine has 8 electrons. 8 electrons around it. Ooh! What in the world? 8 electrons around it. And hydrogen has 2 electrons around it. Okay, that's a cool thing. But what do you notice in here that happens that didn't happen in the first place? Here you have Diego. Here you have Diego. Here you have Victoria.
So they're probably
Different atoms.
with
Electrons traveling in this cloud, and here you have 8. Meaning that, for example, electronegativity of fluorine, which is the most electronegative of all elements, has electronegativity of 4.0. And then hydrogen. Look for it.
what's
Electronegative. How attractive an atom is. Yeah, I like that one. How attractive that atom is. Or electronegativity is the ability to attract electrons from itself. This is the definition of the book. So for example,
some elements have a greater ability of
they have different electronegativity. So itself in the case of one. Did you see, check out the electronegativities of different elements in the periodic table? Where's the, look at the key. It's not there? Yeah, so that QB table doesn't have electronegativity. Boiling point fusion is atomic mass, name, symbol. Well, there are some to the side, it includes electronegativity and crystal structure, bond character, and some other characteristics. So for example, look in the book please for electronegativity. In the table of electronegativity. What I'm trying to say is go to the glossary. Yes, there we were saying, sorry. So for example, any element on that same. Well, okay, listen. In the periodic table, oh, it's in the appendix? I was talking about the index.
a measure.
No, not the glossary, not the glossary, the index. What page? See 124.
91.
Let's go to page 124. Okay, there, page 124, thank you very much. On page 124 of your textbook, you have a table with the electronegativities of all the elements. So you see which is the most electronegative of them all. 124, fluorine is the most electronegative. And this is the least electronegative. The least electronegative. Cesium? Francium. So what trend do you notice in the periodic table of electronegativities?
value.
What trend do you notice? Like which is the most, in what part of the period do you find the most electronegative? Or what part? In the top right.
1.8.
3.3? Not 1.8. The electronegativity difference between those two is 1.8. All you do is subtract the electronegativities. Questions?
But 4.0 minus 0.7.
1.0 minus
2.2, I think 2.2. 1.8. Okay? 1.8. Go back to 124.
The difference between the electronegativity can be a negative answer.
No, it's not necessary. Always subtract that shortest from the highest. Just get the difference as a positive number. Yes? Which brand is that? Calvin Klein? Or Splash? Splash? We call that? Alright. Okay. All right. Questions so far? No? Okay. See ya. No. Let's do calcium now. Calcium. How many valence electrons does calcium have? 2. All right. So, well, you know what? I went too far with calcium. Wait. Yeah, no, I went premium. Sodium. Okay, here we have sodium. Sodium has how many? 1. Chlorine has 7. We have 1, 2, 3, 4, 5, 6, and 7. Yes?
That's the way where you arrange the
Lewis symbol here.
And so it doesn't matter how we place the dot, we can put the DNA on top of the...
No, wait, but there's a problem. How many electrons sodium wants to have in its last energy level? 8. And chlorine?
2.
No, they both have 8. Octet rule. Sodium and chlorine are no exceptions. Listen, sodium and chlorine are no exceptions to the octet rule. Okay? Only hydrogen and folic acid are. Okay?
So they create salt.
No way. So what's going to happen there? Sodium wants to have 8.
They all gonna share.
A chlorine will share to the sodium.
Chemical bond. So they'll
Yeah, mix up.
Okay.
the electrons will form a cloud between.
No, that's it.
Okay, look, here's what happens. We cannot say that sodium is going to. We can't say that sodium, we're going to just put it over here, and then it's going to share its electron because sodium is only going to have 2. Sodium is not happy with 2.
They're gonna combine and share.
There's no sharing here. So sodium says,
One has
let's see. You get rid of this. Sodium, what's up? How are you? Sodium says, I'm sad. Why? Because I wish I could get rid of this electron. But why, sodium? Why do you want to get rid of this electron, sodium? Why? Huh?
Because he wants to meet another.
Obviously, the energy level will also disappear, right? There's no electron. So sodium winds up with 8 electrons in its outermost shell. Yes? So, the story continues where sodium says, alright, chlorine, you may have my electron, and now I am as happy as can be. But chlorine, but here's the thing. How many protons in sodium?
10. I know 11.
11 protons.
Right.
Wow.
When we give away.
There are 11 protons.
Fine. How many protons? 11. What about chlorine? How many protons? 17. How many electrons in this guy? how many electrons total? 10. How many electrons in here? 18 electrons. So what does this mean? This means that this sodium lost an electron. It became more positive. So the sodium becomes a sodium ion, and the chlorine becomes chloride ion. They become ions. And when a positive ion and a negative ion meet, what happens? No, they attract. They attract. But this sodium ion is not only going to attract one chlorine, it's going to attract other chlorides. And these of the chlorides are going to attract other sodiums. And so on and so on and so on until you have a network. A network that has a ratio of 1:1. For every sodium ion, you have a chloride ion. That force of attraction between these two, that's what we call an ionic bond. Okay? That is an ionic bond. What's it? Let me see how the screen doing. If it's doing. Ah. Look at that, they're there. 7. Yeah, Herman's not there. You can go and watch the video back again. Questions so far? Well, because that's the way it's distributed. If you do the electron configuration, you will find on the first level there are 2 electrons, in the second there are 8, and the last one there's 1. You can go ahead and try and do the electron configuration for sodium. And you'll notice that it has 8 electrons in the outer one. Okay, so in this case, let me use narrow for the sake of the ones who are on YouTube. Lost 1 electron, so it has 10 electrons now. Therefore, it becomes a positive ion. Chlorine has 17 protons, but it has 18 electrons. It's more negative by 1. Therefore, chlorine is no longer an atom, it's an ion. It's called a chloride ion. Okay? So we have a negative ion, and we have a positive ion. What happens when a positive and negative? They attract. But this sodium ion is going to attract other chloride ions. And those chloride ions in turn are going to attract other sodium ions and so on, forming a network of a bunch of ions together whose ratio is 1:1. For every sodium ion, you have one chloride ion, because that's the way it works. So we refer to this compound, we refer to it as NaCl, sodium chloride. What is sodium chloride? Sodium chloride is not, listen carefully to this please. Sodium chloride is not a molecular formula. Why? Because that's not a molecule. What is that? It's a crystal. Remember, it's a crystal. What we're representing with this formula, what we're saying here is that for every one sodium ion in this lattice, there is one chloride ion. Okay, we're not saying that there's a molecule of sodium chloride. That doesn't exist. So please don't go to university and say, no, la molécula de la sal. No, that doesn't exist. Okay? So you will not call it molecular formula. You will call it formula unit. Okay, we're going to see that in more detail. Now, if we compare it with H2O, for example, this is a molecular formula for water. Why? Because this is a molecule. This is a unit. A unit that looks like Minnie Mouse. Okay, we have oxygen and two hydrogens bonded to it covalently. Polar or non-polar?
Polar.
It is, again, what do you think? It has to be polar. It has to be polar. How can you tell that this is an ionic bond and this is a covalent bond? Just by looking at the formula.
You have two.
That? Remember, that's the only rule of having a break. Don't go to sleep. Stand up. These 5 minutes are not microwave minutes, they are alarm minutes. You know the difference, right? 5 minutes in the microwave are very long because you're hungry. 5 minutes in an alarm are very short because you don't want to get up. So it's not the same thing. Okay, Maria Fernanda says, can we look for the chemical bond with any element we want? Or are there specific elements we need to use? Don't worry about that right now. Hey, why do I have a crown? Video output low. Only if you share with me halfway. Let's take a look at our sample real quick. Here's calcium. Here's calcium. And what is valence electron for calcium? 2. Draw 1, 2. Here we have chlorine again. And chlorine has 7. 1, 2, 3, 4, 5, 6, 7. So, if you were to look at the electron configuration of calcium, how many energy levels in calcium? 4. Oh no, 3. 4.
Yeah,
4. Alright, what is the atomic number of calcium? 20. It means that it has, at the first energy level, how many electrons? 2. The second one? 8. The third one? You can... Okay, look, it has 2 electrons in the first energy level, 8 in the second one, 8 in the second one. That's 10. How many in the last one?
9. 2.
How many in the last one? 2.
7.
Don't guess. 2. How many in total? 12. How many is it missing? 8. So it has 8 in the third level. Yes? So calcium, what does calcium want to do? It wants to get rid of those 2 electrons. Yes? So that it'll stay with 8 electrons in the last energy level. Yes.
But chlorine only wants 1.
Okay, very good. Chlorine only needs 1. So then chlorine goes and says, hey calcium, adios. Can I have one of those electrons? And then calcium says, sure, you can have my electron. But then chlorine says, why the long phase? Because I still need to get rid of 1 electron. So then what does chlorine say?
Okay, you.
I have a friend. This friend, he also in calcium says, yay. There you go.
Well, how is it that it has a how is it has a friend?
Oh, okay, look. Listen.
Where does the other chlorine?
Okay, listen. Listen. What I'm going to say is very important. I mean, everything I have said is important, so this is important, sir. Very important. Not that. Look. Diego is asking, where does the other chlorine come from? Where does it come from? Now look, here we're talking about chemical reactions. We're talking about bonds. We're talking about 2 compounds, putting them together. Now in here, on the board, I'm only representing 1 interaction of the billions of quadrillions of zillions that are taking place in a small testing. Like, what amount of sodium and what amount of chlorine do you need to react and form salt? Do you have any idea how many molecules of water are in one drop of water? Inimaginable. Calcium and chlorine. There's a bunch of calcium atoms, there's a bunch of chlorine atoms. So where to get them from? That's what you have the most. Okay? But on paper, I'm only representing interaction between three of them. All this is happening in mega splits of seconds at the same time, because you're putting them together. Okay? So, calcium. How many protons in calcium now? How many protons? 20 protons. How many electrons? 18 electrons. 18 electrons. How many protons? 17. How many electrons?
18. 19.
18 electrons. How many protons?
17.
How many electrons?
18.
18. Meaning that calcium becomes positive by what charge? 2 positive. Chlorides are always negative 1 each, because they each one receives 1 electron. So, calcium is a 2 positive ion, chloride is a 1 negative ion. Since calcium is 2 positive, calcium is going to be attracted to 2 negative ions, or a charge of 2 negative, in such a way that this compound, formed by calcium and chloride ions, will have a ratio of CaCl2. For every calcium ion, there are 2 chloride ions. Okay? In the case of...
But for each 2 positive calcium ion,
there will be 4 chloride ions. For every 1, there's 3. Nope. How do you know there's 17 protons in chlorine?
Because of the atomic
What's the atomic number? And how many electrons now? 18, because you added 1. I added 1 electron that came from calcium. Calcium lost 2 electrons.
Is that 20?
Calcium is the atomic number, 20 is the atomic number of calcium, I'm sorry.
Because it lost.
No. Protons never change. It has 18 electrons because it lost 2 to chlorine. So now it has 18 electrons, making this a 2 positive ion. And that force of attraction between these is what we call an ionic bond. Okay, ionic bond. Of course, calcium is not going to attract only those 2. Calcium is going to attract anything that is negative. But then the chloride ions, but 2 chloride ions are going to attract 1 calcium ion. But this calcium ion is going to attract another 2 chlorides, and so on until you have the lattice, the network, the crystal, whose formula unit is CaCl2. Meaning that in 1 crystal of calcium chloride, you have 1 calcium ion for every 2 chloride ions.
what is the crystal?
Crystals.
What is calcium chloride?
Calcium chloride is a salt used for, what is it used for? It's not diet. Diet salt is potassium chloride. I can't remember what calcium chloride is used for. But it's a salt. It's like potassium chloride. Potassium chloride is diet salt. You know what they use diet salt for? It's for people that have too much sodium. So you want to reduce the level of sodium in your blood or in your body. Instead of that, use potassium chloride, which your body will digest better. It tastes horrible. I tried it once and it tastes horrible. Now, if I were to show you this stuff, let's see, we have, since I mentioned potassium chloride, I have H2O. Let's say I have this one. H2O, why not? And I'm going to write this one. If I were to show you a list, can you tell which one of those compounds have been bonded covalently and which ones are bonded ionically? For example, the first one is ionic bond. The second one? Huh? Why covalent? What is the first thing in the chart that I that I wrote at the beginning of the class?
Non-metals.
Sitting on metals. What is potassium? On metal or non metal? Potassium is on metal, right? It's on the far left side of the periodic table. All those guys over there are metals.
So it's a problem.
What did we say was an ionic bond? You say what?
A metal plus
Metal is not metal. So it's ionic. How about H2O? Covalent bond. What kind of bond is represented? It's covalent. Why? Because hydrogen and oxygen, they're both non-metal. How about sodium oxide? Why?
Because one is a metal
Right, one is metal and the other one is a non-metal. And H2S? Hydrogen sulfide? Why ionic? Which is a metal there? They're both non-metal. It's covalent. Got it?
Which one?
They're both non-metal. They're both non-metal. Okay? Okay, so since we said that this one is polar, this one is polar. Polar, covalent, I'm sorry, covalent. Polar or non-polar? Polar, because they're different elements. How about this one? H2S, polar or non-polar? Polar. How about this one? Non-polar, that's an element, not a compound. Well, there are two atoms bonded together. And it's a non-polar bond. Questions so far? Yes? No? Okay, so we're just going to check on the screen to see if one of any of your classmates has a question. In the meantime, let's work on the first section review, so you have to take it for homework. 6A. Huh? No, you're not. We don't take homework for the weekend, remember?
Which one is it?
It's 6A section review. Let's work on that.
From 1 to 6?
Yeah, from 1 to 6 only.
Hello.
Cool. Share the video on Google Classroom, please. Okay, it says in here that I don't even know if we're still live. Oh yeah, look, we're still live. Yeah, I know. Let's get rid of the chat. So I'm just gonna pull the camera facing you. No, it's fine. Yes, please. Okay, the first question says, generally, why do chemical bonds form between atoms? Okay, you can say that. You know, having a bonding means that they're more stable. You can also say that. Okay, to be more stable, or to have a low. Question number 2. I think question number 2 deals with that. Question number. I'm giving you the answers now, all right? So question number 2. State the octave rule. To what elements does it apply? Octave rule is that atoms will transfer, accept, or share electrons in order to have 8 in their last energy level. What are the exceptions according to... Okay, on page 149. On page 149, can everybody go there, please? Trying to help here.
Is there a number on you saying that they want to have 8 electrons?
Yeah, which gives them more stability. Okay, you see on page 149, are you with me? Basics of bonding. Can you read it with me? 6.1 says chemical bonds in the octet rule. The first sentence says the second law. Not that one. The next paragraph. What does it say? Similarly, an atom. The next paragraph. What does it say? Because of these inherent properties. The paragraph after that, what does it say? An atom's stability. Okay, and the other one? The octet rule does not apply to transition and intertransition metals or to the first 4 or 5 elements in the periodic table. You notice that it's a bit dubious, so we're going to stick with hydrogen and null gases. Okay? Question number 3.
Yes, sir.
It's pretty easy. No, to what elements? Oh, I'm sorry. Okay, yeah, all of them except these ones. What are the 3 main bond types that can form between atoms? And ionic. Very good. What chiefly determines the polarity of a bond?
Either or another.
Let me show you the... This is what determines it. Well, actually this... the difference between electronegativity. Or the electronegativity difference of the 2 atoms bonded together. Bond between the 2 atoms of the same metals. But because bond between different elements are not 100% covalent, they become more ionic as they become farther apart from each other, meaning that the electronegativities are different. Difference.
Non-metals have 8 electrons.
When they're in the have the same.
So what would be the electronegativity difference? 0. When the electronegativity difference is 0, they are 100% covalent. As the electronegativity difference begins to increase, they become more and more and more and more ionic. It's like a scale. 100% covalent. Less covalent, less covalent, less covalent. Ionic, 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 ionic. But there is nothing as 100% ionic. Okay, no. So number 6 is? True. True. So there, I solved section review 6A for you. If you want to do it for homework, you can go back to the video. I don't think you want to go back to this video. It's 1 hour 11. You can go to parts, like to pieces of it. Okay, so I'm going to disconnect. I'm going to stop streaming now. Thank you very much for your attention.